triple hydrocarbons. So the basic, get these basic rules down, and then we apply them when we get to other organic structures, okay? So the first thing, when you look at an organic structural formula, okay, so this is a full-blown structural formula, circle the parent chain, which is the longest continuous carbon chain. So take a look here. I'm going to circle this parent chain. So notice these bonds here, it's a carbon dash line to a hydrogen. So I'm cutting through carbon to hydrogen bonds, but my circling does not cut through a carbon to carbon bond. So the longest continuous chain without cutting through a carbon to carbon bond, this is what we would refer to as the parent chain. And the number of carbons in this parent chain, this is a 4-carbon parent chain. Okay, so I'm going to come over here to the hydrocarbon name. So the first part in the name is the prefix, and that prefix represents the number of carbons in the parent chain. And you don't need to do any memorization. You need to go to your table P. And when you take a look at your table P, you go down where N equals 4, that's 4 carbons, okay? You will see a prefix of bute. It's not but, it's bute, okay? The second part of the name, the suffix and how it ends, okay? This is about the carbon bonds. So this is about the bonds in the PC. So when we take a look at each carbon to carbon to carbon bond, okay, all the bonds are single. So we have all single carbon to carbon bonds. And because it is single, we would use the ending ane. Okay, so the suffix, the ending is either going to be ane, ene, or ein, because we have single, double, or a triple bond present. So this structure's name would be butane. This is the liquid in lighters. This is the fluid in lighters. That's its structure. Okay, so condensed structural formula. So this is full-blown structural formula. You will need to be able to go between full-blown structure and the condensed. Condensed structural formulas, they're just a lot easier to write. So when I take a look at this, here is my first carbon. So this carbon, directly attached to it, it has these 3 hydrogens. So CH3. Okay, and then I have my second carbon here in the parent chain, and it has only 2 hydrogens directly attached to it. Here is my third carbon in the structure. And when I take a look at what it is bonded to other than the parent chain, it has 2 hydrogens attached to it. And lastly, my most right carbon. And when I take a look at it, it has 3 hydrogens attached to it. So sometimes you are going to have to write the structural and collapse it down to a condensed, or you see the condensed, and to figure out stuff you need to redraw it. So the parent chain, and then when you see a carbon and whatever is to the right of it, it belongs to the carbon back to the left. So these hydrogens get attached to it. Molecular formula is where we just see something like this. So when we take a look at it, in this one, there's 1, 2, 3, 4. So there are 4 hydrogens. And the total number of H's, I can count them here, or I can add up their subscripts, but 4, 8, 9, 10, H10. So full-blown structural, condensed, molecular and the organic hydrocarbons name. Taking a look at the next structure. So always start off with circling the parent chain. What is the greatest number of carbons you can circle without cutting between a carbon-to-carbon bond? So when I take a look at that, that's my longest chain. So that's my parent chain, and it's 4 carbons, so that means N equals 3. So when I go to my table P, okay, 3, when N equals 3, it shows me prop. Now I need to figure out the bonding. And when I take a look here, I see that not all the bonds are single. Not all of them are single. I see it looks like an equal sign, so that means that there is a double bond. And because there is at least one double bond, I can't use ane, okay? I have to use the double bond ending ene. So this would become propene, the organic name. Okay, so let's write this as the condensed structural formula. So here we go. Here is my first carbon, and directly attached to it, other than the other parent chain carbons, are 3 hydrogens. Here is my next carbon in the parent chain, and besides the other parent chain carbons, it only has 1 hydrogen attached to it. And then I have my last carbon in the parent chain, and besides the parent chain bonds, the only other items attached to it are these 2 hydrogens. And now the molecular formula. So when I take a look at this full-blown 1, 2, 3, 3 carbons, and the number of hydrogens, 1, 2, 3, 4, 5, 6. So 6 hydrogens. Here we go. Last example here. So here is our full-blown structure. First thing, circle the parent chain. So this parent chain, it contains 3 carbons where N equals 3. So when I go to my table P, if N equals 3, I use the prefix prop. And now I need to take a look at the bonds. And when I take a look, it's not all single-to-single bonds in the pink that I circled. So I see that this is a triple bond. So I know that this is not an ane. And when I go up here to take a look, if I have at least 1 triple bond in the parent chain, I use the ending ine. So it's propine. Okay, so now the condensed formula. So my first carbon right here, directly attached to it other than parent chain information are 3 hydrogens. Here is my second carbon, and it has no hydrogens attached to it. The only bonds it has is within the parent chain, so we don't put any H's to the right of it. And then our final carbon, it has only 1 H directly attached to it. So that would be the condensed structural formula. The molecular, 1, 2, 3, so we have 3 carbons in the parent chain. And then we take a look at the number of hydrogens, which is 4. So let's take a look. I notice I have like a little typo here that what I circled in yellow is correct and N equals 3 is correct, but this should be 3 carbons and not 4. Sorry about that.